Let's continue in section 2.1. Now we are going to introduce truth tables. And let's make a mutual agreement from now on. Let's say most lowercase letters without misunderstanding, when there's no misunderstanding, they're going to represent statements. So like when we have a P, that means it's a statement. What kind of statement? It really depends on the context. Okay, so now first of all, the negation of a statement is not P, so we write that. So that's negation of P is not P. Or we call it, it is not the case that P. So that's either not P or it is not the case that P. For example, let's begin with some concrete example. Say let's define statement P as 1 plus 1 is equal to 2. So if you just say 1 plus 1 is equal to 2, basically that's what it says. And when we say negation is, it is not the case that 1 plus 1 is equal to 2, or you just put a not there, 1 plus 1 is not equal to 2, right? You can just say it's not equal to 2. It is not the case 1 plus 1 is equal to 2. That means 1 plus 1 is not equal to 2. Or we just say 1 plus 1 is not equal to 2. Okay, so let's make it simple. I'm going to erase the words, the statement with words to make it shorter. Now, is this statement true? Is this statement true? 1 plus 1 is not equal to 2. Certainly, it is not true. It is a false statement, right? And oops, I'm sorry. Actually, I meant, is the original statement true? 1 plus 1 equals to 2? Yes, it is true. Yes, it is true. Now, is its negation true? Well, by the way, this 1 plus 1 not equal to 2, the negation in statement form, because P is 1 plus 1 equals 2, 1 plus 1 not equal to 2, which is the negation, which is the opposite. That's how we say not P, right? Not P, that's the statement form. Is its negation true? Certainly not true. 1 plus 1 is not equal to true. This will be a false statement. This is a false statement. Now, here's the observation. Negation of a false statement is so like just think about this. This is a false statement, right? This is false. How do you find its negation? The negation, like, you're going to say the opposite. The opposite will be 1 plus 1 equals 2, which is true statement. So therefore, the negation of a false statement is actually a true statement. And the negation of a true statement like this this is a true statement. The negation, which is this statement, is a false statement. So it's a false statement. So here it comes the truth table for negation. So when you have a statement, it's either true or false. This statement is either true or false. If it's true statement, the negation will be false statement, right? If you begin with a false statement, the negation should be true statement. So this is the first result. The truth table for a single statement. For a single statement, this truth table has, if we don't count the heading, it has 2 rows because the statement has 2 possibilities of either true or false. Let's take a look at the conjunction. Let's take a look at the truth table for conjunction. So conjunction means P and Q. So to help you build a table, actually this can be very intuitive, but let's make it more intuitive, concrete. I'm going to create 2 statements. So the statement P is, think about this, 1 plus 1 is equal to 2, okay? So this statement is a true statement, right? And then another statement is candies are sweet. I hope that you don't argue with that. Candies are sweet. So true statement. So if I say 1 plus 1 is 2 equal to 2, and at the same time, candies are sweet. How do you take what's your take on this whole sentence? The whole sentence, because both are true and at the same time, right? They're both true. So this statement will consider that as a true statement. So that means if you begin with a true statement and another true statement, P and Q should be a true statement. You consider true statement. Now let's move on. 1 plus 1 is 2. Certainly this is a true statement. If I tell you 1 plus 1 is 2, and at the same time, candies are not sweet, which is a false statement. So obviously these two do not happen at the same time, right? So therefore, this whole sentence should be considered as a false statement because candies are not sweet. That's false, which makes not happening at the same time. So therefore, this is a false statement. So therefore, when P is true and Q is false, the connective and will give you a false statement. Similarly, 1 plus 1 is not equal to 2. This is a false statement. And no matter what you say here, I already know this is false, right? And at the same time, because this is already false, I know the result is going to be false because these two are not happening at the same time, okay? So even though this is true, the result should be false. Therefore, in my truth table, false statement and a true statement is considered as false statement. And the last one, 1 plus 1 is not equal to 2, which is false. And candies are not true, which is false. So they're not happening at the same time again. So it's false. Now, as an observation, P and Q is true when both P and Q are true, right? When both P and Q are true. So that's important result. We'll be using this all the time. So get yourself familiar with the result. You know, when we construct a truth table, when we have two variables, because there are two possibilities for P, two possibilities for Q, so we do expect there are 4 rows right there without the heading. There are 4 rows here. And you can certainly write it in any order you want, but let's make an agreement. So from now on, we'll use this order: true, 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 false, false, true, false, false, when we build truth tables involving 2 statement variables. Okay, so 2 variables, then we use this order. Now disjunction P and Q of P and Q is P or Q. We write P or Q. We have to be a little careful. In everyday language, in everyday English, or can mean sometimes inclusive or exclusive or. For instance, the book does provide us one example, like when you go out eat and a waiter asks you cream or sugar for your coffee. Well, you could certainly have cream and at the same time sugar. So you could have either just cream only or sugar only or both, right? So in this case, the waiters or actually is inclusive or including could include both. Now, if the waiter asks you coffee, tea, or milk, probably you most likely what the waiter means is just one of those. It doesn't mean you take them all. Like for example, if you and I are in a room and then we say one of us close the door, probably it's either you go close the door or I go close the door. We won't go closing the door together. So that will be another example of exclusive. So this is exclusive or inclusive. This is inclusive. Now, we certainly do not want this ambiguity in our math, right? So now in math, across all the discipline in math, the default meaning of or is inclusive or. That means if you say P or Q, that means P or Q or both, okay? Now, to express the exclusive or, we want to distinguish that from the inclusive or. We write this notation, this circle with a plus sign in it. This is the exclusive or we just say XOR, P XOR Q. This is saying P or Q, but not both, That's how we say it, the exclusive or. Let's first look at the develop the truth table for or. Now, again, when we say this or, we already have agreement here. The or is inclusive or. I would like to use, again, one example to help you develop the truth table. Let's say, suppose one advertisement says, hey, we want to hire instructor, and the applicant must have a master's degree or 3-year teaching experience. So we are going to denote master degree as statement Q, 3-year teaching experience as Q, master degree as P, I'm sorry. So just imagine that you are applying. Suppose you do have master degree and you do have 3-year experience. Are you qualified to apply? I believe so, right? It says either master's degree or 3-year experience. You have both, therefore you are qualified to apply. So when they're both true, certainly you are qualified to apply. Now, what if you have master's degree, but you don't have, so you have no 3-year experience? That means not the case, right? So, sorry. Suppose you don't have 3-year experience, that means false on Q. Q is false. Are you eligible to apply? I believe so, because you already have master's degree. So therefore, yes. So true, false, you're gonna say yes, you can apply. If you don't have master's degree, but you do have 3-year experience, certainly you are eligible to apply because it says or, either or, right? As long as you have one, then you are eligible to apply. And if you have no master degree and you don't have any no enough teaching experience, both are false, you probably don't want to apply. So you're not eligible to apply. So this is the truth table for the or. So please note that P or Q is false only when both are false, right? When both are false, okay? Let's apply the above result. So determine whether this is true or false statement. It becomes quite interesting to do those problems. So this is an or statement. Is 7 less than 5? No, that's not true. So you have a false value for, false value for this guy. Or is 3 greater than 1? Yes, which is true, right? So now from this table, this is for all, for the connective or. So you have false and then the next second one is true. So the result is a true statement. So according to this table, you know this is true statement. You don't have to construct truth table. You take advantage of the truth table already established. 2 is an odd number. Okay, 2 is an odd number, which is false, right? This is a false statement. Or 2 is an even number. So or 2 is an even number, which is true statement. So again, we look at these charts. False, true, and the result is true. This is an or statement. So therefore, we do know this is true. You may try the last one and pause the video a little and then come back. So all cameras use film. And this is an and statement. This is and statement. This is certainly false. LA is larger than Omaha. This is true statement. Los Angeles is larger than Omaha. Now we are going to use the and table. False and true. If you remember false and true, which is this row. and the result is false. So we can say that this is a false statement. All right, this is the second video of this section. We've learned the fundamentals like the truth table for not, for and for all. We are gonna, in the next video, we are gonna actually do a little more comprehensive like combination of those. And then we construct